Hello, guys, and welcome back to another episode of the What's Working podcast with me, Spencer, the Director of Hatch Development. Today we've got Haslen from ENG8. Welcome to the show.
Thank you very much for having me on the show.
So, could we just start with a little bit of a background on yourself and the business?
Sure. I originally basically was an army officer, and then I got into security, and I got into working in Russia, and I worked in and out of Russia for about 25, 30 years now. So it's been quite a long time. Originally, we were investing in material science technology, and now we invest in technology that basically is connected with renewable energy. We have 3 laboratories in the company, plus a demonstration laboratory in Portugal. And we basically specialize in learning to nuclear reactions using plasma. So that's our specialization. I've been one of the co-founders and investors in this business since 2017, and we've basically I've been acquiring some LENR teams along the way, and collaborating with others. So we've got a very good, solid background to learning to nuclear reactions, or might be called catalyzed fusion, and the way the systems work.
Got you. So it sounds like you've got a kind of a technical product. If you could break down your technology for us so we can actually understand it a little bit better.
Yeah, the sitting behind me is a classic example of one of these units. So we have a power supply block, which basically we convert 3-phase electricity into high voltage DC. It then goes into, we call them energy cells, a low energy nuclear reactor. Inside a low energy nuclear reactor, we have 2 different types of reactions primarily happening. We have hydrogen is fusing to become helium, and then it can become heavier elements. But also we see other reactions happening. For example, oxygen becomes carbon in some of our reactions. So there's 2 different types of reactions, and they release heat and electricity, or heat primarily or electricity primarily. So if it's primarily electricity a customer wants, we have a mixture of gases that go in, and we get electricity being produced as the primary output. Or if we have got customers that want high temperature air or steam, for example, then primarily we use a mixture of air and water to basically get that mixture.
Got you. So it sounds a very useful technology. But where can it be used then? Can it be used for commercial buildings, businesses, and things like that, or is it actually made for the day-to-day?
It can be used in a very wide range of applications. So, for example, if a customer wants commercial heat, that's a commercial heat energy cell behind me. And a system about that sort of size would be producing around 100 kilowatts of heat out of a package like that. So effectively a standard Euro pallet-sized object, 1 meter by 1 meter by 1.2 meters, gives us the ability to produce 100 kilowatts of power, whether it's electrical or thermal power. But it can also be made smaller. We have in one laboratory, they're making smaller devices. So this potentially is a 500 watt unit, half a kilowatt, and that's primary electricity out of a unit like that. And we do have smaller ones. So in future, your laptop will probably have an LENR energy cell inside it, and you literally put a drop of water in your laptop once a year to keep your laptop powered. Or if it was, and that moisture can be in the air, by the way, so it could just be going. Your laptop basically never needs charging. Your phone would be on the same principle with the phone. Your phone would never need charging. And then your car, if you have an electric car, you can put an electric car. To power an electric car, you would need a much smaller battery, because your primary energy source is now back on board the car, and you're generating power on board a car. And if you're at a house, you'd have a unit in the house producing heating and electricity for the house. And it's not like solar where you need a large roof. It's a very compact little device. So it would basically either be put down outside your house, like some outdoor heat pumps are at the moment, but and they're pretty silent. So there's almost no moving parts within the units apart from an internal pump. And that's all you need, and they will be lower cost. So currently they are about half the price of solar and wind as a renewable energy tech. So that's about £500 or £500 for a kilowatt, or a generating capacity, or £500,000 per megawatt. And what you'll find that we can operate 24/7, or we can just turn them on and off. So the cost of actually energy out of these machines is probably 5 to 10 times cheaper than you would get out of a natural gas boiler or you would get out of a wind turbine or a solar panel.
Got you. So we've actually had a previous conversation to this, and you described the process and the journey of coming up with a solution as somewhat impossible. So how did you actually go from this is impossible to having a prototype smaller than, like you say, like a PC size?
Well, I guess there's two bits to the impossibility. For many decades now, people have said like low energy nuclear reactions are impossible, and actually they're happening around us all the time in nature. If you look at lightning, fork lightning, ball lightning, if you look at the aurora borealis, they're all basically examples of LENR. When you look at the sun, you will see that the sun's surface is only 6,000 degrees centigrade, but you go a million miles out, it's millions of degrees in heat. Well, that clearly shows that the heat is actually coming from the LENR reactions in the solar corona rather than the sun's surface. So what we did is we basically worked with some really, well, actually the physicists did it first, then we came on board as investors, but the physicists came up with new ideas of how the elements are formed. They are broken down or they're built up, fusion or fission, and they came up with some really novel ideas of how to do it. They basically spent, one team's been on it 30 years, one team's been on it 15 years, another team on it, say, 17 years. So this is deep technology. It's been being in labs for a long time. We're now luckily at the commercialization stage. So how do we go from a dream of some physicist 30 years ago to where we are today in the lab and going into commercial development? So we focus now on commercial energy for people who need megawatts of power, because we can put modular reactors out as 100 kilowatt blocks. So we can service them if there's a repairs and maintenance issue, we can just service them quickly, hot swap them necessary. And where we are, there's 100 megawatts of capacity within the local ceramics and food factories. So we're just focusing on that specific area. Now, to miniaturize it, to really pack it down in small, was also another physics breakthrough that was from Professor George Eggerly. Actually, he's a brilliant physicist, and his team, and they worked out how you could potentially do that, and then worked out how to do it, and he spent years and years doing it. So that system that can basically be in your briefcase or it can go in your car as a small packaging, we've got like 35 engineers in the team or more, scientists and engineers in the team, and they're sort of beavering away probably 5 or 6 days a week, going through this cycle of development to get a product that's compact, reliable, stable, and safe.
So you just mentioned commercialization and things like that. What is your go-to-market plan, and who are you selling to at the minute?
I'm not selling to anybody. We are lining up to sell. We're about 12 months away from supplying commercial heat from the unit sitting behind me at the moment. And we are focusing on people who need either heating for their buildings, heating for an industrial process. So it could be, for example, drying pottery or drying ceramics. And then because we're focusing in the sort of the 250, 300 degrees centigrade range at the moment, where we are very comfortable operating. Now, with the units, we can also go up to around 1,500, 2,000 degrees centigrade, which is really high temperature heat, which is good for metal processing, melting metals. It's good for sintering lower grade ceramics like pottery, for example, and stoneware, which this area of Portugal is very, very well known for. And then we intend to spend the next 2 or 3 years just working to supply local customers. We have locally on this industrial estate, next to us, we have 100 megawatts of requirement. Within 30 minutes, we have 1 gigawatt of requirement. So we're just going to be very, very focused on local customers. And then we will start basically have our system stable enough and reliable enough so we can actually ship to UK. I mean, I'm British, but we can ship to England from Portugal. Weather's better here. So we can ship to UK and other countries and get things working. Also, we're planning on having a production facility in UK. So we were doing a lot of research and development in the UK on applications for the technology 2017, 18, 19, 20, 2000, and then COVID hit. And then everything went to pot in a sense. So we effectively moved to Portugal and we've been moving our team to Portugal. Portugal's our new hub. And we are looking for future customers so people can express interest in that. We're also very engaged in the grant process, which the UK, having done Brexit, still is involved in the European grant system. So we've been getting inquiries from companies as diverse as aerospace to marine engineering to buildings to say, like, can they collaborate with us? Can they do a grant program with us so they develop their product can be developed with us using grants? So where we are, and people can get up to a 65 to 80% grant assistance. So if a washing machine company or JCB, for example, in England wanted to develop something, then this is a great place to collaborate with us. And we're on a big science park base, plenty of laboratory space. So we're trying to find innovative companies who really want to take the next step, like build a JCB, for example, that's self-powering, or build a Dyson vacuum cleaner, for example, that could be, you plug it into the wall, it just powers itself. So yeah.
Wow. So on that point then, looking at like partnerships and strategic partnerships as a whole, if you could really nail down a ideal client, a partnership profile, who would that be? Say if they're listening to this now, who would that be?
Well, a company, for example, like a Greco that's British based, a big generator manufacturer, we could basically collaborate with them on creating or repowering their existing generator technology, or we could do it so that we can create a completely new generator with them. So it'd be a standalone generator, could be 100 kilowatts, 10 kilowatts, a megawatt. And then we're over a 3-year period, we would develop that technology with them so that within 3 to 5 years, they've got a product to put onto the marketplace. So generator companies, engine companies, vehicle companies, of course, vehicles normally have quite a long lead time getting into service, anywhere from 3 to 7 years, depending on the technology leap. So yeah, Aston Martin. We had a meeting with Aston Martin about 4 years ago, but they were going through some changes. So a company like Aston Martin would be great to work with, or McLaren, or Lotus, for example, from Norfolk. UK is a great innovative company for low volume and medium and high volume manufacturing. So yeah, we'd love to get a car manufacturer involved. That'd be great.
Oh, definitely, definitely. It'd be great if you got like an F1 team involved, like that would be solve a lot of the emission problems and the fuel problems that those guys have.
F1 would be fantastic. And of course, Formula E would be great as well, because you don't have to charge up the electric car. It just off she goes, basically. So, and we actually looked at the Le Mans cars,
Yeah.
because they're going 24 hours. And what an advantage that would be. You don't have to pit stop so often and refuel. You just off you go. So yeah, any really innovative stuff, and it doesn't have to be exotic as well. It could be a company like say Rayburn or Arga in the UK that make domestic old-fashioned oil and gas boilers and stuff like that, heat cookers. And you could have an Arga, for example, in your house that you just wouldn't need to have any fuel going into it. It could just heat your house. It could use it for your cooking, and it could produce electricity at the same time.
Exactly, exactly. So just casting back to the start of this journey then, what got you really excited about revolutionizing energy production in the first place?
What got me excited about this? That's an interesting one. I was looking around for something that was really innovative, and there's a lot of conspiracy theories in this low energy nuclear cold fusion tech. And about 20 years ago, a professor basically sort of like said he's got some of this tech, and I thought, okay, we'll leave it. Anyway, we tried to get to him 6 weeks later, and the professor couldn't be found anywhere. And this time someone sent us a video. We looked at it and went, we've got to go see him. So we found him, caught a plane, went to see the professor, sat down with the professor. He showed us a little sunshine in a large jar of water, and he showed us some interesting facts. We went, well, that's just amazing. So what does the planet need? It needs low cost, abundant, clean energy. And so if you imagine, everything that you use, everything you buy, everything you consume is based on the price of energy. And if you could decrease the price of energy fivefold, can you imagine, the extra money you're going to have in your paycheck at the end of the month?
No, exactly.
The energy poverty is a huge thing in many parts of the world, especially in parts of the UK, for example. The old age pensioners, as an example, are homeless, unemployed. They just can't afford proper adequate heating. And that leads to huge health problems. So if you've got adequate heating in your house where you don't have to worry about turning the electric heater on or boiling the kettle, then you can grow plants in your house. Not wishing to encourage people to do hydroponics in their attics, but
No, exactly. Hopefully not. Hopefully not.
that is
Um,
legal. Is that legal in England now?
no, it's not. I don't
Oh,
think.
sorry.
So yeah,
Okay.
don't try that at home, by the way. If anyone listening, do not try that at home. Um, so obviously you're an investor, you're a business guy, and you found this brand new technology that's going to hopefully change the world and give everyone clean energy. But how do you actually balance the scientific nature of it? Let's get it perfect with the mindset of being a businessman and like just trying to get it out there.
It's an interesting one. We thought, or some of our scientists originally thought that you just had to basically fund an R&D thing. But actually, the investors aren't interested in R&D. They're interested in you making money selling product as quickly as possible. So what we've had to do is we've had to take what we've got and try and create a commercial application for it. So if it's to go into an aircraft, it's 10 years away. Cars, 5 years away. Licensing, it's generally 5 to 7 years away. So we had to like, what can we do now that can basically keep investors happy? And that was industrial heating, because most industrial heating is from natural gas or oil. Those are basically, they produce nitrous oxide and other pollutants into the atmosphere, maybe some carbon dioxide, obviously. And it's low hanging fruit. People who run industrial plants in the SME range, they generally operate for 8 to 10 hours a day. So for us, it was like, okay, guys, like, R&D is great, but actually we need to be focusing on something commercial. So the R&D teams are doing R&D, and this lab is basically doing a commercial application. So we're just highly focused on, like, there are customers over the road. We know the customer well. Exactly what do they need? Temperatures, pressures, flow rates. We're focusing on that, and it also gives the R&D guys a focus as well, because they're not like in a never-ending R&D loop. They can just see like that's what's needed now. Let's get it out there.
Got you. And what is it like running multiple different laboratories, R&D operations in multiple countries by the sounds of it? How do you manage that?
Well, before COVID, it would have been, how should I say, before COVID, it'd been quite a challenge to do that. But then everyone got used to Zooming all the time during COVID. So we were very lucky, because during COVID we were stuck in a beautiful forest next to one of our scientists, so we were able to and go backwards and forwards to a laboratory, so that was good. And then since COVID then came out, we could travel to different laboratories, but everyone got so used to Zoom. It's like, why bother getting back on an aircraft? So we basically meet up, I don't know, every 3 or 4 months as of in person. The scientists love coming here because it's really good food and great weather. And yeah, we're Zooming. So we might spend 2 or 3 hours a day on Zoom, just discussing different things between different laboratories. And the collaboration is really fast. So yeah, it's a cultural thing. I think we've all gone through this change. We can work from home. We can basically work from remote locations and all collaborate. So it's really good.
So like obviously looking into the next 3 to 5 years, then there's going to be some major changes with your technology and the implementation of it into the commercial sector, and then hopefully into more of the day-to-day life. But
Yeah.
what's the immediate things that are really exciting you at the minute? What's exciting for you guys in-house?
The most exciting thing is these reactors basically we've been taking electricity from the grid, and we've been producing, say, 5 or 10 times more electricity or heat out than that we consume. So it makes it very profitable, because you buy 1 unit of energy for, say, for example, 10 cents, but you sell 10 units of energy for, say, 50 cents. So it's a good economic model. But actually, we've got to the stage now with at least one of the systems. So we've had it self-powering for 2 hours. So it means we don't even need to connect to any grid. We can just take it to a factory and just plug it in and go like, there's your power. So it's completely off grid. We don't have to have any fuels. We don't produce any emissions. There's no alpha, beta, gamma emissions. The electromagnetic emissions out of it in terms of radio frequencies and things are tiny. So there's no barriers to market entry. We don't have to. It's not like we're like a solar farm or a wind farm where you've got to get very big special licenses to export your energy or export the energy off the roof of your house or a factory. We can just turn up and plug in. It's that simple. And seeing years and years of research and development, actually seeing the customer basically getting ready for accepting our units, for me is exciting, because it means it's like it's coming out the lab and moving forward. So it's really good. And it's very nice to be on that journey with investors. We've got about 100 investors in our investor team. And that gives us quite a bit of resilience, but also we bring in bigger, as we now need more and more capital to scale up. We're bringing in bigger strategic investors, and some big private family offices we're in discussions with. One very large altruistic fund we've been through the due diligence cycle with. So yeah, that's exciting because we've got a new office complex, headquarters, laboratories. We're basically working with the architects to move into. So that gives us space for 100 workers to basically move on site and really drive the technology forwards in multiple applications.
Got you. It sounds like, from what you've just been discussing on this episode, of it's been years and years of hard work and testing and getting things off paper into production and things, and now it's getting to a point where you've got a product to actually implement into businesses first. And the journey of that, what are some key takeaways for our listeners? Our listeners are traditional business people, B2B. Have you got any insights from that complete journey that you could give those?
I think the interesting one is taking a new product and having to fundraise for it, because fundraising, as every business person knows, is a part of their life, unless they're very fortunate to run a very profitable business, and then it's a question of where they invest their money. But from our point of view, it was really interesting seeing obviously the traditional sources of money. Banks won't touch you, VCs, you're way too early, you're pre-revenue. So our greatest insight was the value of social media and being able to connect with thousands of people all over the world. Americans are faster technology adapters probably, and have a larger wealth pool in America. So we've got a good pool of American investors, but we've also got 15% of our investors are actually people now working in the company, either part-time or full-time or volunteer. So we've got investors preparing grant applications for us because they really want to do a certain project with us. We've got investors basically who have a very big project they want us to go into, so they're, excuse the French, grooming us to basically go into a big project. That's on synthetic aviation fuels, for example. We had an investor reach straight out for us after the APEC conference and go, how long can we go to the moon? And they were going, we've got one of our robots going to the moon in 3 years' time. So how much money do you need now to power our unit? So that was exciting. And then Stargate, this huge AI program in Texas. So we were already talking to 2 Texas companies and people in Texas, and they went, like, how fast can you get into Stargate, and how fast can you ramp up? And the energy industry is huge. So, like, for example, they've got a relationship with a company that basically owns a coal-fired power station. It was mothballed for environmental reasons a year ago, and it's 1.7 gigawatts. It's a huge power plant. And so they were saying, like, okay, how quickly can you do it? I said, well, we'll put a production line in your plant. So the first 1.7 gigawatts, and that's over 1 billion, by the way, pounds of actual asset deployed. So it's like, how quickly can you build £1 billion power plant and start supplying energy out of that to our customers? So that was interesting because we were looking at production economics and production technology, and General Electric is a leader in some of these field pool General Electric, people who produce washing machines. Because our system is about the size of a washing machine at 100 kilowatts. And one washing machine, the biggest washing machine assembly plant, could do 1 terawatt of power generating capacity a year of our technology. Not 1 gigawatt, 1 terawatt, 1,000 times bigger.
Wow.
So that was exciting, just talking to people who've got very big budgets and just going like, how can we do it?
Got you.
So it's like, you asked the question from businesses, it's strategic relationships, strategic partnering, and the power of social media for fundraising. We were on a platform, and then it was like, well, actually the platforms are even limited because you've got to go out and promote yourself. So it's through guys like you who've got their own channels, which have access to people that are really interested in our technology. We've raised over a couple of million recently just from people like yourselves.
Wow. Well, it's nice to hear that platforms like mine and things like that are useful to guys like you, because you're definitely doing bigger things than I am currently. So it's nice to be a part of the journey in some way. But just before I let you go, for everyone listening, everyone interested in what you're doing, where can they find you? You just mentioned your socials and things like that. Have you got a website? Where can they find you?
Yeah, you go to ENG8. Echo November Golf 8. It's the infinity sign, should be energy, but we call it ENG8. .energy, and they can find us there. And then there's an there's a contact us investor line, or they can get hold of us through you. So we've got a team basically monitoring the websites and things almost 24 hours a day. Yeah, we're user friendly. We're open to engagement.
Haslen, it's been an absolute pleasure to have you on the podcast. I'm in awe of what you guys are doing over there. I think you broke it down really well, and I hope this episode goes out to people and resonates with them as much as it's done with me. So thank you very much for coming on.
Thank you so much for your time, Spencer.